Alright guys, how's it going? Today I got a little project here. So, being that I'm getting more and more busy with my rifle shop, I got a ton of barrels coming up to do, and I just dread doing that many without a flush system. So I'm going to build a chamber flush system. They're pretty simple, there's not much to them, but they do cost a little money. Step one, of course, is you need some sort of a pump. And here's my pump. There's half of my pump. Here's the other half of my pump. So this is a carbonator pump. This is, I think, a 1/4 horsepower Dayton motor, and this is a Procon pump. These are used in the beverage industry and all sorts of other things. They sell replacement. You can either buy the whole pump or you can just buy the kit. I bought a kit. It was 37 bucks, and of course they get you for $24 for ground shipping for 4 ounces of parts. How that works, I don't know, but that's what they get you for. Anyways, here's all the parts for it, and I'm just waiting on that stuff to arrive. Here I got just a green 3-gallon bucket for my reservoir. This will be my catch tray. It's kind of flimsy, but I'll see how it works. We're going to put our filter in line here, and that will keep all the metal shavings out of our pump, is the idea. I've got a diagram here. I'm not quite sure I'm going to follow this exactly, but I see a lot of guys that build these things, and this is the basic setup for them. So our pump, our catch pan is going to have a drain into it that just drains right back into our reservoir. Here is the basic layout for our pressurized system. These things are set up to go anywhere from 0 to, most guys will run all the way up to 120 pounds per square inch, give or take. Depending on what caliber you're cutting and a few other things, it can vary in what type of fluid you're using. I'm going to run an oil. I'm going to run Mobile Met 766, along with, you dump some Ford ATF fluid in there, about 1 quart ATF per gallon of Mobile Met 766. So I'm going to use PEX, mainly because I have a ton of PEX sitting around from when I remodeled my house. It's super easy to set up, and these fittings are pretty easy to get anywhere you go. I don't know what I have in fittings here. These valves are about $8 a piece. Here is a pressure bypass valve. That is a cheap one from the hardware store. You can buy probably better ones on Amazon and such that are adjustable. This one's set at 75 pounds, so I'm going to run it for a while and see how it works. It might not work great. It might work perfect. I don't know. I think that was 12 bucks. These fittings are $2 to $3 a piece for the brass ones. You could probably get away with plastic. I have plastic ones. They work great in your house, but I'm just going to do these here. So I don't know what I have in this. That's a cheap pressure valve, pressure gauge. That's probably 10-15 bucks, and some miscellaneous parts here. So all in all, you know, I've got maybe 50 bucks worth of parts here. I had all the PEX, and I have a bunch of PEX rings for connecting them. I'm also going to run some tubing on at least the low pressure stuff, and then possibly some reinforced tubing from where our barrel is going to go to our rotary fitting, which I don't have yet. So this is a rotary fitting that some of these kits come with. This is just a cheap air fitting from a hardware store. I think this is like $5 or $7, something like that. But I've heard of these things, they don't work that great. I have on order a Dublin rotary fitting, and you can get them on eBay. I think I paid $40 for the one I got coming, and they're relatively inexpensive considering what the quality you get versus one of these. Will this work? Probably, but I don't feel like testing it and getting oil sprayed all over my shop, so I'm just going to forego this. I actually did buy this about a year or two ago for this exact reason, but I don't feel comfortable with it. A quick rundown of how this is going to work. We're going to have oil flowing in from our pump into a T. This is our pressure regulator, so everything past this point is not going to go any higher than the pressure of this thing. So if we get a pressure spike, this is supposed to be a relief valve, and it'll dump all the extra pressure out back into the reservoir tank. I'm going to put a filter here. This is a shutoff valve for the whole system, so when I'm not using any, when we're done chambering or I want to shut the oil off, this will be a shutoff. This will be my pressure. So we're on barrel pressure side after the pressure relief valve, so we're going to see what our pressure is going into our barrel. And then this is an air bleeder, so when we're done and we want to shut our oil off, we open up this guy. When there's no pressure in here, this is shut off, no pressure. We let the oil drain out a little bit, hook up an air hose, crack this valve, and that will blow. This is going to the barrel. That will blow all of our oil out of our barrel. We should be able to control pressure a little bit with this valve, and this is going to be the main pressure relief. You can adjust it with your pump too a little bit, these carbonator pumps anyways, but that's the gist of it. And then all this is going to get connected with red. I chose red because I got more red than I do blue. So red PEX. And this PEX is rated up to 160 psi at room temperature. I don't ever expect this system to be pressurized above 120. If I ever replace this, I don't expect it to go over 120, 130. So we should be within reason for this pipe. And I did forget to mention one thing. We're not going to use Teflon tape on these threaded portions. We're going to use pipe threading compound. Alright guys, well I ran into a few issues here. So what I think I'm going to do is I'm going to change up my design here a little bit, and I actually had to do some modification. So this is a part, it's supposed to be a fuel filter, pretty sure it's a fuel filter housing, but I modified it. So what I did is I remachined, I probably should have made a video, but I machined a new fitting here. Here's the old one. What this thing was is like a 7/16 or a 3/4 fitting going into the aluminum housing here. And then this is a 1x14 inch thread on here, which is like a fuel filter thread, and it's not a very common one for that matter. Needless to say, I went through and I remachined this. Simple, just threading procedure here. Cut the same diameter in ID there, and instead of a 1x14, I put a 1x12 thread pitch on here, which is pretty much the same for most common oil filters. And I got this huge oil filter. I probably don't need one this big, but it's what I ended up getting. And my O-ring fits on here. So now that guy spins right on there, nice and tight. And so I got a oil filter housing. This piece right here is garbage. I don't even know why they sell those. That's what everybody complains about. So I got that fixed, and what I'm actually going to do is I'm going to put this between my bucket and my pump so it filters before my pump. So that's going to be this line right here. This line is going to come from the pump. So it's going to be underneath there, right off the bucket. But anyways, I mean, this whole system here is pretty much put together as far as barrel out, pump in, excess bleed out. The next thing I did here is I made this fitting, and I don't know if you can see in there, but there is a rubber tipped, like a rubber cone tipped nozzle in there. They sell these things. I think Gray Tan Rifles sells these things for about 150 to 200 bucks, and I think you get, with that 150 to 200 bucks, you get this cheap little $6-7 coupler and a piece of reinforced vinyl tubing. And that's supposed to be your rotary union along with your clamp to your muzzle. I had this piece of, I don't even know what it is, if it's Delrin or what it is, but it's a plastic of some sort, and this is a 3/8 inch to a 1/8 inch. So inside there is the 1/8 inch, I think it's a rubber nozzle tip they call them. It's just a little cone shaped rubber tip that's got a brass 1/8 inch fitting on the back. And so I machined this thing out, and this is, you can see there's the 1/8 inch hole in there. So this is just tightened, the nozzle and this fitting here are just tightened up against in this thing. And then these are 3/8/16 nylon bolts, I believe. And these actually grab onto the barrel pretty good. let me go grab a barrel and I'll show you. So here's a brand new, nice spanky new Hart barrel. I tried this earlier and I had a hell of a time getting it loose. I didn't tighten them down that much either. Tighten these down a little bit. Okay, let's try again. So I can't pull that off by hand. And I don't know what kind of poundage I can put on there, but that's quite a bit of force. So I think that'll work out pretty good. And I had my bolts cost me 79 cents a piece. My little rubber tip in there cost me $6, and this little piece right here I think was $3. So about 11 bucks and a little bit of machining, and this thing was actually already half machined out already. It was already kind of a cup, so I just had to drill the holes and tap them, and for, you know, stuff I had sitting around for about 13, 14 bucks, not even 15 bucks, I got my coupler here, and that'll bolt on my union. Alright guys, well, it's been a week or two here, so I got my Dublin, however you want to say it, rotary union here, and I machined up a coupler here, and I can't remember if I went over that, but there's a rubber fitting, air nose fitting in there. And I actually had to turn this piece right here. So this fitting actually came with a 3/8 inch pipe thread on this side and a 3/8 inch British pipe thread on this side, which is, this is the standard 3/8 is 18 threads per inch and the British is 19 threads per inch. So I had to machine that 19 threads per inch to fit this union, and then our fitting was supposed to be like 7, I don't know. It was supposed to be like 1/4 inch or something like that, but it was actually like a 10 millimeter fitting on this rubber air nozzle fitting in here. So there we go. Now we have this fitting, and hopefully it'll be a good solid fitting for our union. The other thing is, here is our parts for our old pump. I got on with the company that sells replacement pump kits for these things. You can buy all new, you can basically rebuild these pumps. However, when I ordered the parts, I hadn't heard nothing for about a week, and then I called them and they said, we don't even have your order. So needless to say, I got the parts ordered, and then they said they didn't have it in stock. I don't know how the company that sells the parts kits doesn't have them in stock, but I said I needed it, so for an extra 30 bucks I could just buy a whole brand new pump. So I figured, well, they had this in stock, and it's basically the same pump that I have, and this goes up to 130 psi, and there's a serial number on here that shows the flow and all that stuff, but I can't remember what the flow is. But this pump will do everything I need it to do, and it's a brand new pump. So if anybody wants that, I'll send it to you for the cost of shipping. Let me know. But all I'm going to do, I got everything else with this thing hooked up, and so I'm just going to hook these fittings up, and I'm going to run soft line from my pump to my hose, and I'll show you my rinky-dink pump setup down here. Alright, here's my pump system setup. What I have here is basically, this is going to be the line coming from the pump, pressurized pump, and then I'm going to have a line going from the reservoir bucket through the filter into the pump, and then out to our pressure system. But I'm probably going to put a baffle in there halfway in between, and I'm going to dump magnets in there too, so we don't have any magnet or metal shavings getting sucked up into the filter here, but this filter should be enough to keep it from going through the pump. Let's go through and see how this is set up here. So, reservoir gets sucked in through the oil filter, out of the oil filter, into the inside of the pump, out of the pump, up into our line system here. And then if we get too much pressure, it's going to dump out this valve and back into our reservoir. On-off relief valve, or a shut-off valve here. Pressure gauge, oil, air clean out, and then out to our rotary union with our coupler. And then from there, our pan will dump back into this other hole here into the reservoir. Alright, I got it hooked up, and so this is either going to be a complete success or an utter failure. I have this cracked a little bit. Here's my pressure gauge, and of course you got to make sure that your air fitting is closed, otherwise that'll shoot up into the ceiling. Yeah, let's give it a shot here. So I started to see a little go here, so we'll pump it up here and we'll see if we can get it to go. Here's the pretty much complete setup, and it's functioning, and I finished a barrel the other day with it. So a brief little overview. This is my new catch pan, my old black one. I had a 5/8 inch line on there and it just didn't flow enough water through there. So now this is a sink drain with 1.5 inch drain line on there going down to a funnel, which I'll show you in a second. This is just a big Rubbermaid or whatever Tupperware chip pan. And then I have some rare earth magnets in there, and you can see it caught every chip that came down through there, and you can place those in different spots. They also help hold that pan down to the bedways. This is a JGS floating reamer holder. This is their 1.5 inch model, and this piece right here, this is just a plastic cup, and this is it's a plumbing piece that I bought in the plumbing department. It's just a plastic cup. I think it goes like under the sink or something. And then our reamer, of course. I'm not going to show doing any of this work here, but I'll show the fluid. I'll turn it on and I'll hopefully show the fluid pumping here. And there's that drain line coming from the pan into a funnel, and then it goes down to a 1-inch tube that just dumps right back into our reservoir bucket. Alright, and there it is running. As you can tell, I haven't indicated. This is just an example, so it that spins and it flows good, and we get nice pressure. So I get, when it's just sitting idling, it runs about 40 psi. When I run the reamer in there, it gets about up to 80-90 psi, which works out great for flushing all these chips. And as you can see in our pan here, my little catch system, my rinky-dink catch system here is kind of working, but it flows all the oil that's coming in here, goes out back to the tank, and we don't get any flow issues, so that's great. And here's our rotary union, and this, all that does is just sits there and allows that to spin. So that's the whole purpose of that guy. Alrighty guys, I hope you enjoyed that. It was a little bit of a learning process, and I changed a few things as I went along, but in the end it worked out great. As you can see, it's pumping great. A few of the issues I ran into while I was doing it was this pipe dope actually ended up leaking in a bunch of spots. It's not supposed to. I'm pretty sure I properly fit them together, but I ended up switching a lot of it around with this gas rated for oils and gases Teflon tape. It's just a yellow Teflon tape, and this stuff seems to work really good. The other issue I ran into was my return line. Originally it was like a 5/8 inch line, you know, 5/8 OD. I don't know what the inside was, a 1/2 inch maybe. So I increased that from 1/2 inch 5/8 up to 1 inch, and that flow rate helped out tremendously with returning the oil down back to the reservoir. The other thing I did was I got a larger pan, and that pan, I don't know if you noticed on it, but that plumbing fitting, it had a 90-degree elbow right at the end, and when I take that pan off, the whole reason I did that was so I can remove that pan and set it somewhere else out of the way when I'm not using it. And that 90-degree elbow on the end of that pan, and I also have a cover for that. When I put the cover on and dump pretty much all the oil out of that thing and drain it back into the system, I can turn that elbow up 180 degrees so it's pointing up, and if there's a little bit of oil that drips back down in there, it's not going to matter. It's not going to get all over the place. I can set it anywhere I want, and I won't make a mess with it. I might change that whole funnel drain design in the future, but for now, this is how I wanted it. I didn't want it attached to the whole system. So you may be asking, what do I have into this whole system? And give or take about 400 bucks, considering I already had the carbonator pump. I had a used one that I had to buy a new pump for it anyways, but the motor is half the cost. So that pump, I believe, cost me $130. Miscellaneous fittings were like $50, $60. That union was, the rotary union was about 50 bucks shipped, and I had the packs, you know, probably another 50 bucks in piping. And then the other thing is I had to buy oil, so I bought Mobilmet 766, and that was a chunk of change along with the ATF. So, you know, about 400 bucks for the setup that I have right now, give or take a little bit, depending on what you have sitting around. Those carbonator pumps, if you buy the whole pump system with the pump and the motor, they're about 300 bucks. So that's where a lot of the cost comes in with these things, is that pumped
the actual pump. Some of the stuff I made work was like the 5-gallon bucket, the oil filter system, and just using the PEX in general, which ended up working out really well. The PEX was a fantastic way to do this. So I hope you guys got something out of that. It was something that I've been meaning to do for quite some time now. It's I'm doing a lot of barrels lately, and hopefully I can get quite a bit of use out of it. So if you guys enjoyed that, please check out the rest of my channel. I got lots of other good stuff on there. If you want to support me, go over to Patreon, and if you want to check out my website, apexrifles.com, it's another place you can check me out. So till next time, stay safe. See you guys later. Thanks for watching.